Hi, let's take a look at row-level security. In this video, we will cover what row-level security is and why it is important, how the Verb system enforces row-level security, and how to configure row-level security, which will break out into a few separate parts, including active authentication, applying row-level security within a model, and row-level security inheritance within a model. We will cover all of this using a pretty simple but pretty standard e-commerce example to reference. And one last note, this video will be broken into chapters so that you can skip ahead easily as needed. What is row-level security and why is it important? Row-level security determines the data from a model that is made accessible to end users through collections such as dashboards. In other words, row-level security allows you to set and enforce data segmentation rules. This allows you to create collections that are accessible to all or some of your user base, and most importantly, the data that each specific user will see in those collections will be relevant to the permissions they have in your system. So here's an example. Let's say you have an e-commerce ticketing platform with numerous sports organizations as clients. You may want to provide those organizations with KPI tiles for things like orders placed and total events and revenue collected, what have you. And you want the data on those tiles to be segmented by organization. They are the same tiles for the Cleveland baseball team as they would be for the New York baseball team. They're from the same collection, from the same model as we saw, both built within Verb, but the data served is specific to each organization. So how do we set it up to work this way? How is row-level security achieved? First, let's point out that there are two important features or components within Verb that work together to enforce row-level security. First, active authentication. Second, row-level security. We'll get granular with each of those in the next few chapters of this video. Now, your system will make an initial SDK request for a collection, such as a dashboard, in which a client-side authentication token is passed. Verb will then make a callback to your authentication service, an endpoint of your specification, passing the authentication token, allowing your server to validate the user and return identifying details. That's active authentication. The identifying details, roles, and claims are used to filter the data. That's row-level security. Now let's get into them in more detail. Now let's take a deeper dive into active authentication and consider how it works with row-level security. Active authentication is configured on your organization settings page, so let's take a look at that. As previously mentioned, when a user loads a page with a dashboard, your system will make an SDK request for that collection. The JavaScript snippet for which is provided on the collections page in Verb. In that SDK request, your system will pass an authentication token, which, as you see here, is a required request parameter for Verb's callback. So, Verb will then make an API request to your authentication service, passing that authentication token. Here on the active authentication page, you set the method, the endpoint, as well as any headers or body for that request. Now, a quick important note. Anything surrounded by double curly braces, whether in the header, endpoint URL, or in the body, will be set as a request parameter, meaning the JavaScript code embedded into your platform to make the initial SDK request will account for that parameter. Then, your system will validate the user and respond with identifying details, roles, or claims. At least some of these properties must be user mapped in Verb. Once mapped in Verb, these properties will be available for row-level security use. That is, to be used to set data segmentation rules. So next, you'll see an example model and how to use these user map properties to apply row-level security. Let's take a look at a model and recall our previous example. we said we have an e-commerce ticketing platform for sports organizations. And here in our pretty simple example model, we have 7 tables from 2 different data sources and 1 data view built here within Verb. We have organizations that host events and sell tickets. We have the events that the organizations host. We have tickets purchased for those events. We have orders placed to purchase tickets. We have customers placing orders and the page views from those customers visiting the events pages and age ranges of customers. So let's say we want to build a collection of KPI tiles from this model for maybe total orders and total tickets sold and maybe some other things. And we want the users from each organization to be able to log in and see the same KPI tiles as other users from other organizations, but with data relevant to their respective organization. So where do we apply row level security? Well, in this example, it's pretty clear where we'll want to apply the row level security logic, and that's not just because I've already applied it here. On those KPI tiles that we mentioned, we want to ensure that the logged in users see the total number of orders placed only for the organization that they belong to. And the same would be true for total tickets or any other KPI. So in that case, we would apply row level security on the organization table to ensure that any data we show from any table in this model will be data relevant to a specific organization. A general rule of thumb is that row level security is often best placed at the head of a model where all other table relationships flow from. When the total orders placed KPI tile is loaded, Verb will check if there is any row level security applied to any table in relation to the orders table, whether that's a primary, secondary relationship, or even beyond. If they are in the same tree, in this case they are, Verb will force traverse and do a join to show count of orders that had tickets sold for events that belong to the organization that the logged in user has permission to. How do we know what organization the logged in user has permission to? Our answer will be in how to apply row level security. How to apply row level security. Let's open this one up and take a look. We could do that by clicking on the table here in the model and then clicking on row level security. Or in the left panel, you'll see that there is a badge on the model that row level security is applied to. You could click on that badge. Simple enough. Now, remember, with active authentication, your system will provide properties related to the logged in user that have been user mapped in Verb. So in this case, there's a company ID returned from the authentication service that has been mapped to user.companyID. So Verb will take that user.companyID and check if, in this case, it equals to a value in the column ID of the organization table. And now referencing back to that KPI tile example, Verb will ensure that the total orders in the KPI tile is for tickets from events that are tied to that specific organization. Now, additionally, as you'll see, there are numerous ways to configure this to suit your objectives. There are a variety of comparisons to use, and you could add numerous clauses and Boolean logic. It's also worth showing the mechanics of adding row level security logic to a table that doesn't already have it. It's not much different from what I've already demonstrated where we edited row level security, but I'll show you anyways. Click on the table, find the row level security option, click there. So that's one way. And the other way would be to find the table in the left panel and click on the ellipses and find row level security. Simple enough. Before wrapping up here on the model, let's talk about inheritance. I touched on it a bit, but I want to point out a few more things. Here we have row level security logic applied on only one table. But do note that it is possible to apply unique row level security on separate tables in the same model if that serves an objective for you. So let's take a look at this model with row level security applied to two tables. And there we go. It is important to note that there is no need to apply the same row level security on multiple tables. In fact, that may be detrimental to your efforts. So let's take a look at what we have here. On the organizations table, we have a user map value of user company ID equal to the column ID of the organizations table. Now, if we look at the events table, row level security applied there is user mapped value of user company ID equal to the column organization ID. So that's a duplicate of what we have in the organizations table, and it's not necessary. So let's get reset here. Row level security will be applied anywhere tables are connected within the model. If you have an isolated table in your model for any reason, that table will not be subjected to row level security that isn't directly applied to that isolated table. So let's disconnect age range here and see what happens. Okay. Now we'll see there is a distinct badge to identify tables that fall outside of row level security. Additionally, down here, there's a warning to let us know how many tables fall outside of the row level security logic. This is especially helpful on more complex models than our example here.